Hello everyone. Thank you for joining us today. In today's webinar, we will be covering some of the modeling features of ETAP, as well as the reporting deliverables that are available. Included in this webinar is the new plot manager and Excel reports using Python scripting. We will cover many of the new features included in the new ETAP 18 series, as well as discuss capabilities that were developed in previous versions. ETAP provides many new tools to streamline building a one-line diagram or importing a model and the data from third-party software. Models from other programs can be imported, including Revit, Excel, and many others. Today we will be going over some of the new modeling capabilities and import features in ETAP 18, as well as additional tools provided for your one-line presentation views. We are going to focus on the new features from ETAP 18, including tooltips, line jumps, bus connections, new capabilities with remote connectors, and other presentation tools that will help you in your engineering analysis projects. In the Data X menu, you can select from a list of options to import or export your model. This will increase the efficiency for your project and reduce the risk of errors when rebuilding a model from scratch. One of the first items I want to pull up is the Data Exchange Manager. The Data Exchange Manager is used with our ETAP app. Here you will find the summary of all the exports from the main project sent to the app, all the imports from the app sent, and what's been done. With ETAP 18, we also released the first version of the ETAP app. The app can be downloaded from a Microsoft Store or Apple Store for any Windows tablets and Apple iPads. Using the ETAP app, you can collect data, build and modify the one-line, take pictures, and transfer the information to the ETAP software to perform electrical system and design and analysis, including all your studies such as load flow, short circuit, protection coordination, as well as arc flash. The model can be managed as a nested one-line diagram using composite networks to organize different portions of the model. Once an element is selected, you can modify the data using the tabular view, containing the properties associated with that equipment, including breakers, configuration statuses of protective devices, adding new elements, and this can all be synchronized to the master project. And once downloaded and uploaded, all the changes are instantly reflected on the master model. Bidirectional synchronization allows engineers and project managers to exchange project information from either the app or ETAP. Project managers can send the complete network or specific sections of the model to any engineer and receive edits or additions made from the field. The ETAP app interface is done wirelessly through internet connection, either remotely or locally. This provides a one-to-many operation, allowing simultaneous users to manage and work and edit projects at the same time while sending this information back to the project manager. The project manager can then accept and reject any new data changes, additions, and modifications, and all actions are logged for auditing. Don't forget to download the ETAP app from the Windows or Apple Store to increase efficiency and start using the app for data collection now. Some of the other data exchange interfaces I would like to highlight are a few that we added to the ETAP 18 series. One of the interfaces that was added was Autodesk Revit. We also added an interface for our GIS systems, including Multispeak, Sim, and enhancements to our existing GIS interface. Our geospatial diagram provides an editable environment for electrical assets and connectivity compliant with geospatial data. This information can be imported from the third-party systems as mentioned and modeled directly into ETAP. ETAP then automatically generates a substation view, feeder diagram, equivalent circuit, and allows analysis and editing done on multiple layers. Results from your studies can then be displayed on the OneLine diagram as well as the geographical background, providing a seamless view of the power system within ETAP. In the near future, we will be doing a webinar on our GIS system, so for now, I just wanted to cover an overview. But please stay tuned to our schedule so you can watch the webinar on the GIS system in ETAP. As mentioned, we have also added a new interface between ETAP and Revit. The ETAP Revit data exchange simplifies the electrical design process by utilizing the data already in Autodesk Revit to automatically generate electrical models into ETAP. Once the models are in ETAP, you can run system studies for all your calculations, validate the electrical OneLine, and of course, the synchronization between the two products improves the overall engineering design quality. This reduces significantly the hours needed to perform a project because you no longer have to build a model from scratch between both programs. And then this avoids duplication and incorrect data entry. There is a direct communication between Autodesk Revit and ETAP, so make sure you get the add-ons from Autodesk Store and utilize the ETAP Revit data exchange process. Now that we have our main project in the model, let's go ahead and make some edits and changing using some of our tools. I'll use AutoBuild to add additional equipment to this MCC. Once I select the bus, I can just click on the motor multiple times to add different motors to this equipment. Now I can highlight the selected equipment and use our alignment tools to align the motors where I want them. Apply my preferred data block positions, and then I can select the motors and click the breaker once, and it auto inserts on all of those branches. Now you see here, this motor is 200 horsepower, and these motors do not have any horsepower because they're blank. I just added them. So now I'm going to select them, right click on motor 7, click Control Shift, right click, and it's asking me if I want to replicate the properties in motor 7 to the other selected elements. Once I click yes, now motor 7's properties have been pasted to all the motors I recently added. The Copy Global Paste data was recently added to ETAP 18. You can do this through the OneLine diagram in the right click as I just did. Or I can do it with the Data Manager as well. In the Data Manager, I can select one of the equipment types. In this case, we used induction motors. I can pick one motor, hit Copy Select, and select other selected motors, hit Paste. So this is going to copy motor 4 to motor 9, 10, and 11. If I click yes, I've now just taken the data of motor 4 and sent it to motors 9, 10, and 11. So again, we can use this during the right click or the Data Manager. Going back to our MCC, another new feature that was implemented was an enhancement to our data blocks. You could see the data blocks I have decided to show in the OneLine diagram. But now, if I point and pull the tooltip, you'll notice that the tooltip is constructed of the data block with additional parameters. This allows me to see more details on a part-time basis as to not crowd the OneLine diagram. It is really easy to modify. When you open the data block editor, you will see all the properties that's been selected. You can do properties or results, and once you have selected them and built the data block, you choose to select which ones you want to include on the data block itself that's currently displayed, or for the tooltips. And it's pretty easy too. By a checkbox, you can include or exclude any of the properties within a data block or a tooltip. What you also may have noticed that was added to ETAP 18 are these icons that show the connection points to the bus. We've added connection points, also line jumps. So now if you have lines that are crossing in multiple directions, line jumps clearly show which device belongs to which component, is connected to which component, and the new icons on the bus clearly show what is connected from that equipment to the bus itself. These changes are set by default so that you should notice them as soon as you open your project in the latest ETAP version, which is currently 18.1.1. You will see the reflected changes as soon as you open your project. Another enhancement that was added for OneLine clarity for extremely large projects or small projects, either way, is the ability for remote connectors now to be inside or outside of a composite network. So you can see that I have this distance relay, and it's connected to multiple remote connectors that are going to different CTs and PTs throughout the system. So all of these items have been added to enhance the OneLine appearance and improve the quality of the OneLine diagram. It also makes it easier to trace and track throughout the project cycle. Another feature to note was added is the ability to create unlimited views, including views that are specific to the zoom and panning windows. Now this will create visual insight to critical information anywhere in the system. I can go in the zoom window, and instead of just zooming into a location, I can hold Control, highlight the selected area, and we will create a window for this area. This way, if I change to a different composite network, but this happens to be a critical area in my system that I want to track even when I'm running studies, I can keep an eye on it. I can run different studies. I can receive the results across the main network, the selected zoom views that I have, and any other composite networks. So again, if you want additional visual insight on different portions of the model at different times, you could create these temporary views or permanently select views utilizing the composite networks as well. And since ETAP does allow different presentations and different views, you can customize a look and feel to the theme editor or through the graphics of the OneLine diagram. A method you could track of both systems together is under the Windows menu. Windows, click Sync Presentation. Now with Sync Presentation selected, I can zoom in on one of my presentations, and on the other one, as I click, the presentation is automatically going to move the selected element, keeping both of these presentations in sync for different purposes. So one, you can see the whole model, and the other, you can zoom into the selected equipment. So again, under Windows, click Sync Presentations, and you can sync multiple presentations to keep track of the device that you're working on. I've just covered a few of the abilities of ETAP modeling and OneLine presentations, the look and feel. We still have existing tools you can take advantage of, such as composite networks, themes. We do have videos on many of these, but at this time, I wanted to focus on the newer items that were put in for the ETAP 18 series. And now that we've gone over a lot of the modeling and data exchange capabilities, I'm going to pass it to Tanush, who is going to go over the reports and deliverables available, including some of our existing ones, some of the new ones in ETAP 18, as well as one of the ones we are working on beyond ETAP 18. So you'll want to stay in for the end of Tanush's presentation so you can see the latest tools we're working on for reporting and deliverables.
Thank you, John. Now that we've looked at the modeling capabilities in ETAP, let's focus on the reporting and deliverables. Before we get to reporting and deliverables, we need to understand analysis scenarios. ETAP includes a multi-dimensional scenario concept that consists of various solution parameters such as generation, loading, pre-fault voltage, fault location, dynamic modeling information, and so on. It also includes presentations or the views on which the scenario is being executed. It may also include configurations or the switching status of various protected devices such as switches, breakers, relays, and so on. It may also include configuration information such as the switching status of various protected devices like switches, breakers, fuses, and so on. The multidimensional scenario may also include different engineering revisions or properties. The most basic engineering revision is called base, or the as found or as built system. But as an engineer is doing different analysis such as protection or arc flash, he may choose to create another revision called recommended. A recommended revision could hold all the relay settings based on an optimal or revised coordination study or based on an arc flash mitigation analysis. Once these multi-dimensional scenarios have been defined and created in ETAP, they can be executed singly or in a batch using various study wizards. The very first study wizard in ETAP is called a scenario wizard. It allows the user to run a single case or scenario. A study wizard allows you to run multiple cases defined or multiple scenarios, which could be just for a single study like load flow, or it could be for various study types. That is, running multiple load flows and running multiple short circuits at the same time. You can take this concept one step further with the project wizard, where you can run multiple cases, that is multiple load flow cases, or multiple studies such as load flow and short circuit on multiple projects. So in this case, ETAP actually opens a project, runs the cases, closes the project, and opens up the next one to run cases on the next project. This is particularly useful if you have split the system based on feeders or substations and you're actually analyzing these systems independently from each other. So with this background, let's see how this is applied inside ETAP. The first step would be to define the scenarios. For that purpose, you can choose the revisions, the view, the configurations, and the study type. So in this case, let's say we switch over to load flow, and then define the study cases and the output report names. Once you are happy with your selection, you can simply go to the scenario wizard, click on new, and the program automatically captures all the settings in all of these drop-down boxes so that you don't need to specify them again. You can of course adjust them from here if you'd like to make any minor modifications. You can also choose to rename the scenario to a scenario of your choice and simply press run right from this dialog. The results are displayed on the OneLine diagram directly for you. Similarly, you can go to the study wizard, define n number of scenarios. So in this case, I have defined 5, and execute the scenarios one by one. As soon as the cases are completed, the output reports have been updated. You can now proceed to doing further analysis of all these scenarios. This is particularly useful when you have made one minor modification, such as changing a percent impedance on a transformer or correcting the length of a cable, and you want to just quickly update all your reports one more time. You can simply define these scenarios at the beginning of the study, press run at every single juncture or every other change that's being made, and simply update your output reports. Now that we have a general understanding of scenarios and wizards, let's talk about the reports. When we talk about reports, there are two different categories of reports. The first one being a report that generates information related to the power system model, and the second type of report are analysis results. Listed below each of these are the capabilities exist in ETAP for generating power system model reports and analysis reports. The power system model reports include things such as load tickets or induction motor data specifications, a schedule report manager where you can generate MCC bus tabulation reports, transformer tabulation, cable tabulation, and so on, a load analyzer that allows you to generate a connected load report without actually running a load flow calculation, panel schedules which generate the connected as well as the operating load based on code demand factors. You can also use Python script to generate an Excel report, and you can also generate a report in Excel using the Excel open format. Graphical information can be exported using DXF, Metafile, and more. When it comes to analysis reports, we traditionally use crystal reports to give us a full color tabulation of our input data as well as the analysis results and summaries. We can also use the result analyzer to analyze multiple scenarios or cases and generate an analysis report. We can generate a device settings report that can include the as found as well as the recommended revision data. We can also generate graphical reports using a plot manager. Further customized reports such as arc flash labels and work permits can be generated using Microsoft Word. And finally, we can also use Python script to Excel to generate our analysis results and use various techniques such as conditional formatting and so on that are included in Excel. For the case of our demonstration or webinar, we're going to focus on these few items. We'll show you how to use Crystal reports and export the Crystal report into various other formats. Get an analysis report out of the analyzer, get a device settings report that goes across base and revision data, use the plot manager to get graphical information, and finally use scripting to generate Excel-based reports. So let's talk about Crystal reports, which are full color, user customizable, and summarized tabular reports. The Crystal reports includes analysis results such as load flow, short circuit, and so on. It features a built-in viewer that allows you to very quickly navigate through various pages. You're able to export this information to Microsoft Word, Excel, rich text format, PDF, whatever your word processor or viewer of choice is. You can also generate schedule reports such as cables, transformers, bus and load tabulation information. It includes user customizable templates so that you can use Crystal Report Designer to either edit an existing template that's provided by ETAP, or you can create your own. You can also create user customizable categories. What that means is you can even add additional tabs which are company specific in addition to complete input, result, and summary. So let's take a look at Crystal reports through the ETAP application. Once our study has been completed, in order to get the Crystal report, simply click on the report manager, pick the category of your choice, select the section of the report that you would like to view, select your viewer of preference, and click OK. As soon as the report is generated in the viewer of your choice, in this case PDF, you can actually scroll and navigate through the report and see all the different pages or sections. You can see that the report has been very clearly formatted, and you can continue on to printing the complete report or other sections of the report. You can also select sections of the report through this drop-down list and click on, let's say, complete, and click on the report generation button. And what the program again does is, in this case, uses the default built-in viewer and shows you all the different pages or sections of the report, which happen to be about 15 of them, and you can navigate through each one by one. The same information can actually be exported to Word or Excel. Let's try Excel. So go ahead and click Excel in our list here. For our losses, click OK. And as soon as the Excel report is generated, you can essentially see that all the data is put into individual columns. So this information is put into individual cells, and it can be clearly reformatted or migrated to other formats. Let's switch gears over to the result analyzers. We've looked at analysis scenarios. We can see at the output of the analysis scenario, we can generate a Crystal report, which is the result of a single study. But what if I want to compare multiple load flows, multiple arc flash, and multiple short circuit results from different study wizards into a single tabular or graphical report? Well, that can be done through the result analyzers that are available in these modules, where you can sort results from multiple studies. You can find the worst case results, color code and filter the analysis results, and finally export the requisite or required information over to Excel for including into your study report. So let's see a demonstration of this in ETAP very quickly. In order to understand how the analyzers are working, let's once again quickly go to our study wizard. Let's add one more study into our list, which we had just defined, called LF3. So we have 6 in our list. Let's go ahead and run all these cases, and we have all our results prepared and stored. So let's quickly go over to the load flow result analyzer, and you can see the output from all these different cases that we've just run in our tabular view. So the columns are essentially listing all the reports, and the rows are listing the components that are being reported. So you can quickly see a graphical matrix of information, and through color coding, red being critical and magenta being marginal, which are the worst case conditions or scenarios that are being executed. So we can see 100B and 200DF have some red, so that needs further investigation or analysis. Similarly, we can look at our percent loading, and we can see that again LF100B has a lot of overloads on our buses, so therefore that needs further investigation. So this information that you visualize in the result analyzer, you can simply press export, click on the analysis report and click OK. And once the results have been exported, ETAP automatically opens up the Excel file where you can see all the general information, the bus information including the color code, branch, load, and source information. And you can further customize what you want to view by adjusting the analyzer and generating the report of your choice. Similarly, we can switch over to ArcFlash analysis and bring up the ArcFlash analyzer, where we can again see similar information. You have different study reports, which are again shown in the column. They're color coded, in this case based on PPE hazard category level, and the rows indicate the component that's being evaluated. In ArcFlash, you can actually proceed to do one further item, which is to show the worst case incident energy. So this actually is giving us across every single bus what is the worst case energy level and from which output report was it derived from. And this actually cuts down on the analysis time significantly, so you don't have to spend the time doing manual comparison of these results. And once you have this tabular view, you can just simply press export, give it a name, and once again you get similar information exported into Excel, which you can neatly copy and paste into your study report. Another type of report that's available in ETAP comes from the Star Protection and Coordination module. This one is a device settings report generated in Excel. The purpose for this report is to provide a tabular comparison of the as-built, which is the as-found system, versus the recommended settings. If you recall, I had earlier mentioned that you can create revisions for the as-built relay settings or as-found relay settings and the recommended or the optimized relay settings. So this report gives us a comparison between the two settings. So you can easily put this into your report and highlight which relays have changed or which fuse sizes have been changed, and of course the reason why the change was made. These new device settings are stored in Excel, and these Excel reports are basically templates. So once again, the user can modify these templates, or you can contact ETAP to see if we can customize it for you. It also includes sorting and filtering capability. You can also sort by adjacent bus or by substation to quickly narrow or pinpoint the device settings that you're after. So let's take a look at this inside the ETAP software. Now we'll take the same example of ArcFlash, and at this point in time, let's just focus on bus 1. So we'll just zoom into our bus 1 here and temporarily just turn off our data blocks so we can focus on the result itself. We'll go ahead and run our ArcFlash study on the entire network, but again focusing on bus 1, and we can see that the incident energy is level C. Now this is in my base or as found condition. So let's say if I was to go ahead and create a new revision, and we call this revision recommended. The instantaneous capability would actually be added to our recommended revision. So let's go ahead and add the instantaneous in, run our ArcFlash study one more time. So you can see that the incident energy is now level A. However, if you go back to base and run the same calculation one more time, you will see that it's level C. So now there's clearly a difference in circuit breaker 22 settings across base and revision. So you can simply go into our protection device mode, bring up the device settings report. We select all our devices to include revision versus base, or simply revision information. In this case, we want to compare revision and base, so let's click OK. We'll give it an output report name, and as soon as the report has been generated, the program automatically launches Excel. So you get a nice cover page that's telling you the basic project information and the fact that this is base plus recommended revision. And whenever you see a revision, it's going to be in this greenish blue color. So as you flip through the device settings report, you can see that for fuse there's no change. And let's just quickly go into our low voltage breaker. So here we can see that there is a change on circuit breaker 22. It appears twice, and the note basically is telling us that the revision setting is different from base. And we can see what the difference here is clearly, that the instantaneous is disabled or defeated in base versus it's enabled in revision. You can also use this report to get status of the device rating if it's different from the library. What that means is if you have manually modified a component in the editor that does not match the library, it would also be indicated and reported here. So this device settings report includes all the protective devices such as overload heater, fuses, and various trip units, including the panel breaker. So anything that's different from base and revision in these protective devices will be clearly indicated in this report. This report therefore saves tremendous amount of time trying to collate and consolidate the information, especially when you're trying to create a final study report for a customer. The next type of deliverable that we can look at is a graphical deliverable through the new plot manager. So the plot manager allows you to do multi-study plotting in a brand new interface using the latest technologies and visualization. You can save the plot styles, of course, as templates. It also lets you automatically compare consecutive studies, has all the features and capabilities like zoom, pan, auto scale. And then most importantly, the results that are generated in the plot manager, they can be exported individually or as a batch into Excel. So let's take a look at the plot manager capabilities very quickly inside ETAP software. In order to demonstrate some of the capabilities inside the plot manager, we're going to take the advantage of the harmonic program. So inside the harmonic analysis program, we can first of all go ahead and run our harmonic load flow, and we can see that we have certain results shown on the OneLine diagram, so we can sharpen them up a little bit by switching our theme here. And we can see that there's about 22% current distortion and 10% voltage distortion. So let's see what bus 1 looks like when it comes to the spectrum itself. So let's go ahead and click bus 1 spectrum, and we can see what the spectrum of that bus looks like. You're actually able to print this particular report straight into PDF, so you essentially get a exact replica of the plot inside the PDF file. Or you can also export the selected information into Excel, select the values again, and you can plot the same exact chart in Excel as well, and customize it further if you don't want to do that inside the plot manager. In order to demonstrate the capabilities of the plot manager, let's take help of transient stability module. In the transient stability module, let's go ahead and define an event on our main bus where we're placing a fault for a period of time. And let's copy this event to sustained fault. In sustained fault, we would like to go ahead and deactivate the fault removal so that the fault stays on the system for indefinite period of time. And we have another case where the fault is then removed after 100 milliseconds. So let's compare these two cases in the plot manager. So step 1, let's go ahead and select our sustained fault and go ahead and run our transient stability case. You can of course visualize the impact on the OneLine diagram by moving the time slider and seeing the various results, but of course it's much easier to understand in terms of a plot. So let's go ahead and take our generator plot here, get relative power angle, megawatt, and speed, and let's plot it. And as expected, the generator is actually going out of step. So let's go ahead back to ETAP and take a case where the fault is now cleared within 100 milliseconds, and go ahead and run this case again. Note that I'm overriding the same output report. We can go back to our plot manager here and uncheck overwrite and press refresh. And as you can see, a new chart or new line has been added, which shows a stable generator profile and a stable generator speed and a transient in the megawatt that returns back to normal. So we can now compare the power angle speed megawatt for a generator for a sustained fault versus a fault that's cleared in about 100 milliseconds. And with this, you can use the program to easily find the critical fault clearing times and the critical isolation times for various disturbances in the system. You can also set this option to auto refresh. So when you come back to ETAP and let's say the fault was not cleared in 100 milliseconds but cleared in 200 milliseconds, once again we can go ahead and run our transient stability case, go back to our plot manager, and as soon as the results are updated, you can see the previous result and the new result superimposed on top of each other. So the plot manager is able to keep one previous result and the new one, so you can easily do a side-by-side comparison of the results. Once again, you can go to export. You can either print all the open plots, which generates multiple pages of the comparison as we can see on the plot manager, or you can simply select on export selected or export all and send these charts to Excel and plot them in Excel. The final type of deliverable that we would like to go over in this webinar are Python reports. Python is a scripting interpreted language that can be used to generate information out of ETAP in conjunction with the project database or the output report database, or a combination of the two. Python report in ETAP 18 series are pre-scripted reports that generate information in Excel. The information is generated through the calculation engine into an output report database. The script mines this database and sends its information to a custom Excel report template. This information is repeatable and can be customized by changing the Excel template. So let's take an example of a pre-scripted report that is available in ETAP 18 series. In order to demonstrate this pre-scripted Python report, let's switch over to time series load flow. Time series load flow is basically a type of load flow analysis where you can run multiple cases of load flow with multiple loading and generation as function of time. It's particularly useful if you're trying to do any renewable projects, or you want to understand the impact of loading change or generation change in the complete network, or the effect of it in the complete network. So let's go ahead and open up our report manager as before, and here you will notice that you just have one choice, which is MS Excel. So if you go ahead and click on complete, press OK, the Python script is executed in the background and the data is sent over to Excel, and very quickly you have an Excel established report. So it has a nice cover page, gives you all the information in a tabular format, gives you the alert information which you can very quickly go in and also set up a filter if you want to simply filter based on a particular type of device. So that makes it very easy to do. You can get the time series profile information, and you can also include or embed Excel charts so that when the information is put into the template, the charts are updated automatically at the same time. So the Excel reports essentially give you a lot of power and control over what information is being exported out of the result database and how it's being displayed into the Excel template itself. Now let's take an example of a user scripted report. In order to understand Python scripting, first of course we have to look at the Python script itself. So here's a quick example of a Python script written to extract information from a SQL database and the output report database into Excel. But the nice thing about it is it's being done in parallel, so that makes the whole process a whole lot faster. And because it's a script, you can easily adjust and customize what information you are extracting and displaying into the Excel report. The Excel report itself can be customized, and the look and feel of it changed, so it can be reused over and over again. So let's take an example using ETAP. So in order to execute the script, we're going to use our load flow analysis program. So we're going to go ahead and run load flow study here, and we can see the result is 98.61%. So when we go over to Python and execute the script, we can see that we have some basic information about bus, which is coming from the project database, and then we have some information about the load flow results that's coming from the result database. And as we can see, bus 1 is 98.6% here. So if we go ahead and let's say delete and save this template, and you notice that the conditional formatting has been deleted as well, close this Excel template, and we can go back to ETAP, and let's say in one of my results I have changed the transformer tap, and we've rerun the study, so we will essentially get a voltage that's higher than 98.6%. So in this case we get 101%. We can go back into our script, rerun the script again, and this time if you look at bus 1, the result is 101% as expected, and the conditional formatting changes the color from yellow over to green. So this is a quick example of using a Python script to extract data from the project database as well as the output report database.